Okay, so welcome to the next video in our series. I hope you're enjoying it. This is a specimen jar, and this is how the samples arrive in histology. I'm talking about this guy. And you can see it has a cap, and there's about 45 to 50 ml in there. Volume, a very specific reagent. You'll need to learn the name of that because I'm going to ask it. It has the abbreviation NBF. Okay. And those letters stand for N for neutral, the B for buffered, and the F for formalin. Now, formalin is a chemical that we use to preserve tissue. And the word we use for preservation in histology is fix, or fixation. So this patient sample is a Trifine Biopsy or bone marrow biopsy. It's taken with a fairly long needle. It's about 5 millimeters, 2 to 5 millimeters in diameter, and we bore down into the bone, and a specialist removes the bone to check the cellular component of the bone marrow. So the investigation is usually for leukemias. Now, when it arrives in the laboratory, we need to, obviously at registration, if it's a new sample, it needs to be checked. The details on the label needs to correspond with the details on the request form. As you can see, the sample is very fragile. Here's a petri dish to give you a size comparison. And that's a standard hospital label over there, size. So it's a very small sample, a bone marrow biopsy. And that's probably about 2.5 centimeters. And it has to be decalcified. The calcium component needs to be removed because we can't do much with it if it's still hard and calcified. The takeaway from this image, thanks to the credit is below the video, is that you, the prospective histotechnologist, has to be mindful at every level, at every point, that this is a patient and this is a human being waiting for a result. It's very easy for these samples to get lost at the station where the dissection takes place. They roll off, they can be lost very quickly or broken and become destroyed in a way, less than optimum. So the first step in the processing is the arrival of a tissue specimen in its specimen jar. And it's our job to make sure that there is enough of this fluid in there. This is vital. Without a fixative, the tissue will undergo autolysis or putrefaction, which is decay due to bacterial attack. That's the normal bacterial in the tissue or on the surface of the tissue once it's removed from the body. And autolysis is self-lysis due to the fact that the cells rupture when they are removed from the body. That's the cause of post-mortem decay, those two processes. So after the specimen's been registered, we have the next phase of the tissue processing. The tissue, what shall we call it? Making of a glass slide for a pathological investigation. That's what we should call it. It's a long sentence, I know. And the next phase is to take that organ out of the specimen jar and to record its details and remove the pathology so that we can narrow it down. There is no chance that we're going to get this entire organ onto one glass slide. Now this is the uterus over there, and then the vaginal cavity and cervix. Sorry, my bad. The cervix at the bottom here and the uterus above, and then the two ovaries. And then here you've got the fallopian tube. So this is an enormously damaged cervix, uterus, ovary. This says uterus with adnexa is usually the technical terminology is used. And you can see the right, if we're facing the patient anatomically, this is the right ovary is enlarged with 3 lobulated masses, 1, 2, and 3. Ovary is lobulated, and there are 3 discrete nodules. Then you've got the fallopian tubes, and another one on this side. And then this is just the shell, or this cystic space ovarian cysts are quite common. Here appears to be a mass, and that is the cervix. Okay, the point here is not to analyze the pathomorphology, a macroscopy of the organ, but just to mention that the pathologist will sit with you at a dissecting bench, and he will help remove the appropriate pathology to place them into smaller plastic containers called tissue cassettes. Okay, so this is called the cut-up station, CUT-UP, or dissection station, and it has a really well engineered ventilation system, as you can see there. And above this pathologist, you'll find also evacuation, sometimes even below. The key here is not to get any of the formaldehyde into the respiratory tract. Formaldehyde vapor, formaldehyde is carcinogenic over a long period of time exposure. This is stock photography from Alamy, and it's just so brilliant. You can just ignore the print over there. This is a typical dissection knife used by the pathologist. It could even be a medical laboratory scientist, Histopathology qualified. We also cut up organs. The key here with this image to share with you and for the test upcoming quiz is that the appropriate pathology is removed from the organ submitted. So big organ submitted, in this case it's a kidney. There's a ton of, as you can see, this yellow, which is adipose, mesenteric fat, and then the pathologist will dictate into a microphone and describe what he's seeing, while you, as the histotechnologist, if you're not doing the cut-up, will write it down onto a histology work form, or whatever the laboratory calls it. And then you will place representative samples, you or the pathologist, into these smaller containers, which I said were cassettes. They've got a holding compartment, but they also have a lid that shuts down. And onto the cassette, you've written the barcode. This is the code that was generated when you registered this patient into the laboratory initially, and it can be punched into the system and traced, bringing up all this patient's details, right? What's important here is that when you cut the patient sample, that you keep it under 5 millimeters in thickness, because penetration of reagent is important in the process that follows this stage. The process that follows this stage, funny enough, is called processing or tissue processing. And so, you know, to fill a cassette, chock-a-block, as they say, with tissue, is just going to hinder the efficiency of that. The fluid, there's little holes in these cassettes, I'll show you close-ups, and so fluid needs to get in there. A number of different kinds of fluids, we'll talk about it in the next photograph, and they will be hindered if there's too much tissue packed into these cassettes. On any given day, in a busy day, usually you're looking at about 250 to 350 of these blocks. And per organ, it depends on the size of the lesion. Does that make sense? So in this case, they're only using 3 cassettes. So they'll record it on the work form as A, B, or C, or 1, 2, or 3. They'll also tell you what they've put into each one. So one might have renal capsule, 2 might have renal parenchyma, or you see there's a lesion here, so it might be a renal cell carcinoma. They're not sure, they want to see. And then they will record NR or R. Some use another. It depends on your laboratory, the terminologies that they choose. But NR and R, they use it the NHLS, which stands for no reserve, nothing was left over. We took all the tissue and put them in a cassette, or reserve, there is left over. And that's helpful to the pathologist and the lab staff. Should they want to go back and cut some of the organ, they can just check on the work form. It'll tell them there is reserve left over, or there isn't, or there is reserve left over. Let's go have a look at some of the cassettes one gets.